Good morning.
Good morning, ma'am.
Okay. Okay, fine. So we have started with the acids and bases in the last class, right? So we'll start with the new lesson today. Okay. The new lesson is metals and non-metals. Okay. So that is a third chapter of your textbook, metals and non-metals. So what do you know about metals and non-metals? You know the word metal, you know the word non-metal, right? You know or you don't know? It was there in the 9th standard. Metals and non-metals was there. The lesson was there. Metals and non-metals. Yes, it was there. Correct? Okay. So what do you know about metals and non-metals? Any idea, basic idea about metals and non-metals? Do you have any basic ideas?
Metals are conductor of electricity.
Yes, metals are a conductor of electricity. Good. Then? Okay. Yeah.
Thermal conductivity.
Thermal conductivity is also there in case of metals. Yes. Okay, we'll start with them and we'll learn more about the metals and non-metals. Okay. The first we'll start with the properties of metals. Okay. So what are all the properties of metal? The properties includes whatever you told now. So the first property of metal is most of the metals are solid around us, correct? If you see the iron, copper, or steel, any of the compounds, if you take, these metals are solids in nature. But there is one metal which is liquid in nature. That metal, we call it as mercury. Have you heard the term mercury? Yes, mercury is a liquid metal which is present around us. Have you seen the liquid metal mercury? Have you seen that? It is a black color or somewhat grayish in color. Have you seen the color? It is there in your lab, school lab, it is there. Not there. It's there. Okay, you have seen that mercury, right? Yeah, in thermometer also mercury is there. Yeah, you might have, all of you have seen thermometer. Thermometer also contains mercury. Okay. Okay, that is the first property of metal. That is, metal is solid except mercury. Okay. The second property of metal is the metals are hard. We all know that these metals are hard in nature. Okay. So but still there are some metals which are soft in nature. The example is lithium, potassium, sodium. These are all the substance which are soft in nature. Why they are soft in nature? The main hardness of the metal is because of the strong metallic bond present between the metal atoms. So between the metal atoms or ions, there will be a strong metallic bond. And we all know that the bonding involves only valence electron, correct? You know that concept? The bonding involves only the valence electron. Yes or no? Valence electron means outermost electrons, correct? Yes. So when we consider lithium, the atomic number of lithium is 3. The atomic number under lithium or below lithium in the periodic table, we have sodium. Below sodium, we have potassium. Okay. So all these which are present in the same group in the periodic table has the same number of outermost electron. So if we consider a lithium with the atomic number 3, the outermost shell contains, or the outermost electron is 1. Since there is only 1 electron which is available for the bonding, the metallic bond formed in case of lithium, sodium, and potassium are not so strong. Because of the weak metallic bond present in case of these elements, these metals are not that hard. The rest of the metals like iron, copper, if you consider, they are all strong or a hard metals which is present. The next property is all the metals have luster. They are shining, they have shine. Okay, why do they shine? Because the metals means there will be a presence of free electron. Metal conduct electricity, you told. They conduct electricity because of the presence of free electron, which are free to move within the metal. And these free electron will absorb the light from the atmosphere and they reflect the light, complementary light. Because of the reflection of the light, the metal will be having luster or shining. That is the one more property of the metal. The next property is the metals are malleable. You know that the metals can be converted into thin sheets. That property of metal, we call it as malleable property of metal. The next is the metals are ductile also. Ductile means they can be drawn into wires. We can see that the electricity will be transformed to a house, or electricity will be supplied to a house through a wires, electric wires, which contains copper in it. Because we can convert the metal into a wire, the supply of electricity becomes more easy. So that is a main one more property of metal, that is metals are malleable as well as ductile. The next property is that the melting point. So what do you mean by melting point? What do you mean by melting point? Any idea about melting point? Have you heard the term melting point? Yes, the melting point means the temperature at which metal melts. Okay, so the temperature at which the metal melts, that temperature we call it as melting point. So when we consider a melting point, the metals are having high melting point. The high melting point of the metal is mainly because of the strong metallic bond which exists in case of metal. Because of the strong metallic bond, the melting point of the metals are high. But there are some metals which are having low melting point. The low melting point exists because of the unusual structure in a solid state. When the metals are having unusual structure, the metals becomes unstable in a solid state. In a solid state, if they are unstable, they always want to be present in a liquid state. So they are present in a solid state, but they are easily converted into a liquid state because of the unusual structure. So that unusual structure, or the metal having unusual structures, are gallium and cesium. So gallium and cesiums are the metals which are having unusual structure. Okay, and they melt when we take it in the palm of our hand. That is also one of the property, that is high melting point of the metal. The next property of the metal is about the boiling point. The boiling point depends upon the molecular mass of the metal. So all the metals are having high molecular mass and they are having high boiling point. That is a one more property. The next property of the metal is they are a good conductor of heat and electricity. We all know that they are a good conductor, but the metal like lead and mercury, which are not that good conductor, which are a poor conductor of heat and electricity, mainly heat. The reason for the poor conductivity is lead always present when it is exposed to the air. The lead combines with the oxygen and forms lead oxide, and that lead oxide does not allow the lead to conduct the heat or electricity. And one more case, mercury. Mercury is very thick metal which is present in the liquid state. Because of its thickness, the heat cannot move from one place to the another place. That is a one more reason why, that is a reason why the lead and mercury are poor conductor. The one more conductivity is the electrical conductivity. They are a good conductors of electricity. The good conductivity is because of the availability of free electron, which is present in a metal. Any doubt in a physical property? Any doubts? Okay. Next, we have to see the properties of the non-metal. When we consider one more type of the compound which we consider in this unit, that is non-metal. So what is, okay, one more property we have left, that is a sonorous. We all know that the metal will produce the sound. Okay. The next is about the non-metals. We'll study the physical properties of non-metal. The first physical property of metal which we studied was the metal is hard and they are present in a solid state. But non-metals, most of them are present either in a liquid or a solid gaseous state. Some are present in a solid state. For example, we can consider carbon, sulfur, phosphorus. These are all the metals which is present in a solid state. Whereas the liquid state, we can consider a bromine water, we say, that is a liquid state. And in a gaseous state, we have oxygen, we have nitrogen, we have hydrogen, etc. All these are non-metal. So non-metals are maybe present in a solid state, liquid state, or a gaseous state. So all the three states of physical states are of matter can be found in case of non-metals. The next property, the non-metals are soft. Why they are soft? Because of the weak bond exists between them. If it is in a liquid state or in a gaseous state, anyhow, the interaction will be very, very weak because the molecules are a little bit away from one another. But in case of solid compounds, that too in case of diamond, which is a form of carbon, that is allotropic form of carbon, that diamond is hard in nature. The hardness is because of the strong covalent bond exists between the carbon atoms of diamond. So that is a second property, that is about the whether they are soft or they are hard. The next property is with respect to the luster. These are not lustrous in nature, which means they are not shining. But there is one non-metal, iodine, which is having shining. Why iodine has a shine? The iodine is a last element of the 17th group. If you start the 17th group starts as a fluorine, then comes a chlorine, then comes a bromine, then comes iodine. So since iodine is a last ion, and when we move from top to the bottom of the periodic table or in the group, the size of the atom goes on increases. So as size of the atom increases, the outermost electron will be very much far away from the nucleus, and that electron are free when compared to the other electron. Since they are free, they absorb light from the atmosphere and they reflect back the light. And because of that reflecting of the light, or because of the transmitting the light, the iodine has got shining. Whereas rest of the non-metal like carbon, we know that at home the carbon will be there. The carbon is not shining, and we have a oxygen in the atmosphere. Anyhow, we can't see the oxygen also. If it has a shining also, we can't see it, but the oxygen does not have any kind of shining. So that is a one more property of the non-metal, that is, they does not have any luster. The next is they are not malleable or ductile. So if we beat the non-metal, the carbon will be present when we heat the wood. When we heat the wood, we get a carbon, correct? No, that carbon which will be obtained, the coal or a coke which we obtain, that is a form of carbon. And if you beat that carbon, you can get a powder, you cannot get a sheet or a wire. Not malleable, not ductile. The next is about the ductility. The next is the metals which are solids and liquids have low melting point. Usually we consider a melting point for our solids only. So the low melting point is because they are soft solids. Soft solids are having low melting point. The next property is about the boiling point. The boiling point of these metals are also low. Again, the low melting point comes into picture. The next property is non-metals are bad conductors, as you already told. They does not conduct electricity because they does not have free electron for the movement. If there is no free electron, no movement of electron. If no movement of electron, no conduction of electricity. The next point is about the conductivity of electricity and heat. Both depends upon the case of free electron. They have given that except graphite, which is a good conductor of both heat and electricity. The good conductivity is because the free electron present between different layers of graphite. In graphite, the carbon atoms are linked to one another to form different layers. And these layers are held together by a weak bond, and that weak bond contains electron in it. Since it is a very weak bond, these electrons are almost, we can say that, free electron. And that free electron is responsible for the electrical conductivity. The next one is they are not sonorous, which means they does not produces any sound when it is beaten. So that is about the properties of non-metals. Any doubt? Any doubt, students? Okay. So the next we have to study about some of the chemical properties of the metals. So what are all the chemical properties we have? First, we study the chemical properties of the metal. So when we study the chemical properties, the first chemical property is the reaction of metal with oxygen. So first reaction is, how do metal reacts with oxygen? Most of the metal reacts with oxygen to form corresponding metal oxide. For example, if I consider a copper, when a copper is heated, it combines with the oxygen to form copper oxide. You can see copper here. The copper combines with the O2, that is oxygen, to form CuO. Why CuO? Because the oxidation state or a charge on oxygen will be -2 and charge on copper will be +2. The +2 -2 cancels each other and will get CuO. The oxidation state is +2 and -2 in both copper and oxygen. We can also consider another example, that is aluminium. When aluminium is heated, it combines with the oxygen to form aluminium oxide. In this case, you can see the formula as Al2O3, because the charge on aluminium will be +3, the charge on oxygen will be -2. Here, the charges were same, so they cancel with one another to give a copper oxide. But here charge on aluminum is +3, which is different from oxygen, which is -2. So the charge on oxygen will come as a subscript of aluminum, that is Al2, and the charge on aluminum becomes a subscript of O, that is O3. So they form aluminum oxide, that is Al2O3. Then in order to balance it, we take 2 Al2O3 will be formed when a 4 aluminum combines with 3 molecules of oxygen. So that is a reaction of metal with the oxygen. And this metal oxides which are formed, if they are made to react with water, they always forms bases. Since the oxide produces base with the water, the oxides are called as basic oxides. So any oxide, when they react with water, if it gives base, then that oxides are called as basic oxides. So most of the metal oxides are basic in nature. Okay, so you can consider any example. For example, sodium combines with the oxygen, or potassium combines with the oxygen. So when a sodium combines with oxygen, we'll get sodium oxide, and sodium oxide further combines with water to form sodium hydroxide. So oxide of sodium combining with water, giving a base. Oxide of potassium combining with the water, giving the base. If there is a formation of base, then that oxide will be called as basic oxide. So the metal oxides will always produce a base when it reacts with water. So this are called as basic oxides. The next are some of the metal oxides are amphoteric also. Amphoteric means what? Amphoteric means the oxide which shows acidic property sometimes and which shows basic property some other time. So since it shows both acidic property and basic property, that substances are called as amphoteric substances. The best example for the amphoteric substance is aluminum oxide, which is also called as alumina. Alumina is an amphoteric oxide. When this aluminum oxide combines with the both acid as well as base to form corresponding salt and water. So since aluminum reacts with the acid to give a salt, the formation of salt indicates that this must be base, because acid base combines with one another and will get a salt. Similarly, since the aluminum oxide combines with the sodium hydroxide to give a salt called sodium aluminate, that salt formation indicates that the sodium hydroxide combines with the acid. So aluminum oxide can show both acidic property as well as basic property. And that together we call it as amphoteric property. So aluminum oxide and zinc oxides are amphoteric oxides in nature because it shows both acidic property as well as basic property. Any doubt in reaction with oxygen? Any doubts? Okay, we'll move to the next part then. So the first reaction which we studied is reaction of metal with the oxygen. So the next one, the reaction, okay, the one more we can see the why do different metals are having different reaction with the oxygen. So why the reactivity of metals are different? We can consider the metals like potassium, sodium. They are soft metal, we have told in the beginning itself. Since it is a soft metal, it reacts vigorously with the oxygen and easily catches fire. Because of that reason, we keep that in a, we store the sodium and potassium in a kerosene so that it will not be exposed to the oxygen. Some of the metals like magnesium, if we consider, it burns brilliantly, which means it produces a very shining, which we cannot see in a naked eyes, okay, which produces very bright flame when it is heated with the oxygen. The next is we can consider iron. Iron glows when it is heated. It will not burn so easily. Iron will glow. You have seen that when we start heating the metal iron, it first changes to some other color, like from black or a gray, it will be converted into a blue, then finally to the red. The red color of the metal or the iron glows very brightly. We have seen that. Okay. The next is about the copper. When the copper is heated, the copper also does not burn, but it gets the coating of black coating when it is heated with the oxygen. The next metal, that is silver and gold, these metals are called noble metal. Noble metals are the one which does not react very easily. So silver and gold does not react very easily even if we heat it in the presence of oxygen. It stays as such if we made it react with the oxygen. So it is called as noble metal. The next is some metals like magnesium, aluminium, zinc, lead forms oxide layer over it, which prevents further oxidation. So when a metal like aluminium, magnesium are exposed to air, they readily combine with the oxygen and forms metal oxide. For example, if aluminium is heated with the oxygen in the present exposed to oxygen, aluminium oxide will be formed. That aluminium oxide once formed does not allow the molecule or does not allow the aluminium to undergo further reaction. So the layer of oxide which is formed on the surface of a metal, that is called as protecting layer. So that protects the metal from the further reaction. Okay, so that is the sum of the reactions of different metals with the oxygen. The next we have to see the properties or reactions of with the water. How do metals react with water? So first we consider the metal which combines with the water and it forms either oxide of the metal or hydroxide of the metal with the liberation of hydrogen gas. When metal reacts with water, see, you can see sodium reacts with water, we'll get sodium hydroxide and hydrogen, potassium to give potassium hydroxide, calcium to give calcium hydroxide, aluminium to give alumina or aluminium oxide, iron to give iron oxide. And in all these reactions, one thing is common, that is liberation of hydrogen gas. So all the metals or most of the metals combines with the water and forms corresponding metal hydroxide. And this metal hydroxides, along with that, there is a formation of hydrogen gas. The next is the reactivity of different metals with water, which is different from one another. The first one we can consider a sodium and potassium. Soft metals again, they also react vigorously with the cold water and forms corresponding hydroxide and hydrogen. And this hydrogen catches fire because of the high reactivity or a high the violent nature of sodium and potassium. The next, if we consider a calcium, calcium reacts less vigorously when compared to that of sodium and potassium, but it also forms calcium hydroxide and water, and they does not carry, not water, the calcium hydroxide and hydrogen will be formed, and which does not catches fire. Next, we can consider the magnesium. The magnesium reacts only with hot water, which means if we take a cold water and if we made it to react, or magnesium is made to react with the metal, the reaction does not takes place because the magnesium require higher temperature for the conversion of the water into corresponding hydroxide with the liberation of hydrogen gas. The next one is metals like aluminum, iron, zinc react with the steam to form metal oxide and hydrogen, which means the high temperature is required for the conversion of iron oxide or iron to iron oxide and zinc to zinc rust. So this is about the reactions of metal with water. Any doubt? Any doubt? All are listening or sleeping? Okay. The next is we need to study the reactions of metal with acids. So this we have already seen under acids. So when acids reacts with the metal, what happens? We have seen this under acids and bases and salts. So the metal reacts with acids and form salt and hydrogen. Okay, so the metal will liberate hydrogen from the acid. So that is the first point. We can consider an example of magnesium, aluminum, zinc, and iron. All of them made to react with the hydrochloric acid and they combine to form salt, and along with that the hydrogen gas will be liberated when the metal combines with the acids. The second one is the reactivity of various metal which we have listed are in the decreasing order. The order of the reactivity they have given: magnesium greater than aluminum, greater than zinc, greater than iron, which means magnesium has a more tendency of liberating hydrogen gas from acid, whereas iron is having lesser tendency to liberate hydrogen gas from the acid. Okay, the next thing is the copper and silver and gold does not react with dilute HCl. They are noble metals which does not react with dilute hydrochloric acid. The next is the hydrogen gas is not evolved. So in the above examples which we have taken, the hydrogen gas was evolved at the end of the reaction, but the hydrogen gas will not be evolved when metal reacts with nitric acid. Why? There is no formation of hydrogen gas. The reason is when a nitric acid is a strong oxidizing agent. Oxidizing agent means the substance which helps in oxidation and itself reduced. So the metals does not combines with the nitric acid because nitric acid oxidizes hydrogen into water, because oxidation means addition of oxygen, removal of hydrogen. So the addition of oxygen takes place when the metal made to react with nitric acid because of the oxidizing nature of nitric acid. Any doubt? Any doubts? we can consider an equation for this. That is copper combines with the nitric acid and it produces copper nitrate, water, and nitrogen dioxide. So there is no liberation of hydrogen in this equation, which means hydrogen gas will not be liberated. We'll move to the next one. The next is reaction of metal with metal salt solution, which means if we take a copper metal, reaction of copper metal with its salt solution. Salt solution means copper sulfate is a salt solution of copper, which combines. How that salt solution of a particular metal reacts with its own metal, that we need to see. Okay, so the reaction of metal with the metal salt, how it takes place. So when a metal is dipped into a solution of metal salt, the reactive metal, that is more reactive metal, displaces a less reactive metal from its salt. Okay, from the salt solution, it will displace, that is more reactive will displaces the less reactive metals. That reaction we call it as a displacement reaction. For example, if there is copper sulfate and a copper in it, the copper, if it is more reactive, then it takes up or it will take up the copper salt or a copper metal from the salt. So that is called as displacement reaction. So magnesium and copper, if we take, magnesium displaces copper from copper sulfate solution. When we consider a reactivity of magnesium and copper, magnesium is more reactive, so it displaces copper from the copper sulfate solution. So you can see this, magnesium combines with the copper sulfate. So copper will be displaced out of the metal or out of the salt and will get magnesium sulfate and copper. So similarly, we can consider zinc and copper. In that, zinc displaces copper. The same equation again, the zinc replaces or displaces, both are the same, the metal from it. The next is iron displaces copper from copper sulfate solution. Again, copper will be removed from the copper sulfate. You can see the experiment. In this case, in one of the test tube, we have taken blue colored copper sulfate solution. To this, we are adding magnesium. When a magnesium is added, what does the magnesium does? Magnesium takes up the copper, or the copper will be taken away from the magnesium, or the position of copper will be occupied by the magnesium, and copper sulfate becomes copper, the magnesium sulfate becomes magnesium. Magnesium becomes magnesium sulfate. So once the magnesium sulfate is formed in the test tube, the blue color of the copper sulfate, it will be disappears and will get the colorless solution. The same we can also consider by dipping iron nail in case of the reaction mixture, that is copper sulfate. So after leaving for some time, we can see that the solution color changes to little bit green. Okay, the solution color changes to little bit green. Since iron is more reactive, iron will take the place of copper. Okay, and the copper will be remains as such. Okay, so that is about the reactivity of different metal with its salt solution. So more reactive always displaces the less reactive metal from it. Okay, any doubt, guys? Any doubt? We'll move to the next slide then. The next slide is regarding the arrangement of the metals. So how we arrange the metal, 1 second. Okay, so reactivity of a different metal. So I told that the more reactive metal displaces the less reactive metal. So in this case, what should happen? Which is more reactive, which is less reactive, that we need to see. Okay, so reactivity of the metal can be studied by considering a series. In the series, the metals will be arranged in the decreasing order of reactivity, which means more reactive metal will be kept at the top, and as the list goes, the reactivity of the metal goes on decreases. We can take the sum of the metals which are listed: K, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. So these are all the metal list they have given, etc. So in that, potassium is more reactive, whereas gold is less reactive. So if we see the decreasing order, the most reactive one is potassium and sodium, which vigorously catches fire. The next comes from zinc, iron, lead. They are less reactivity, whereas the gold and silver, they are least reactive towards the reaction, any chemical reaction. Okay, no displacement or any reaction takes place in case of silver as well as gold. So this is about the reactivity series of the metal. We have different metal, and these metals are arranged in the increasing order of their reactivity. So the most reactive one is potassium. The next reactive one is zinc and below. And the last one is gold as well as silver. Any doubt? Any doubt? Okay. Next, we have to see how metal and non-metal react with one another. So when we say a metal, I told that metals are having the free electrons in the valence shell. So when we compare a metal and non-metal, the metals are having more tendency of giving the electron or donating the electron, whereas non-metals are having more tendency of gaining the electron or accepting the electron. So when a metal reacts with the non-metal, metal gives electron to the non-metal and non-metal accept electron from the metal. Okay, we'll take some of the example for that. So metals being less energy required for the removal of electron, they easily loses electron and becomes positive ion and are called as electropositive element. So we can consider first example, that is sodium. So what is the atomic number of sodium? 11. When you write the electronic configuration, you arrange it in K shell, L shell, M shell, like that, right? So the electronic configuration will be like 2, 2, and 6 will be there. In L shell, the maximum number of electrons are how much? 8, I guess. In M shell, it is 18, correct? No? So the electron distribution will be taking place, and this sodium is ready to lose the electron, and the configuration of sodium will be 2, 8, 1. 2 electron in K shell, 8 electron in L shell, 1 electron in M shell. And if it loses this 1 electron, the outermost shell contains 8 electron in it. If there is an 8 electron which is present in case of any element, that element is found to be extra stable. So in order to attain the extra stability, sodium readily loses its electron and becomes Na plus, that is positively charged ion. At the same time, we can consider one more example, magnesium. Magnesium contains 2 valence electron in the outermost shell, that is 282. So 282, so by removing the 2 electron, we'll get octet structure, that is 8 electron in the outermost shell. So because of that reason, magnesium readily gives its 2 electron to become magnesium 2,8. Magnesium 2 plus with the electronic configuration 2,8. So metals are the one which are ready to donate electron to the non-metal or any substance which is ready to accept. Why? Because by losing the electron, the metal will get the more stability. How does the non-metal reacts? So non-metals, as I already told, they gain electron and becomes negatively charged ion. And this property is of non-metal is called as electronegative element, or this non-metals are called as electronegative element present in the periodic table. So why do they accept the electron? For example, if we consider chlorine, the atomic number of chlorine is 17. And the electronic configuration of chlorine, so it gains electron to become Cl minus. When we see the electronic configuration of chlorine, you can see that the outermost shell will be having 7 electron in it. If it gains 1 electron, it will becomes 8. When the outermost shell will be having 8 electron, the compound will be extra stable. In order to have that extra stability, the chlorine will gain the electron to become 288 configuration. We can also consider an oxygen where the atomic number is 8. Oxygen also have more tendency of gaining the electron and becomes O2 minus. So it forms oxide ion. So in case of oxygen, since the atomic number is 8, the electronic configuration will be 2,6. To becomes 8, it has to gain 2 electron. So it gains 2 electron and becomes O2 minus. So based on the number of electron required for the stability, we write the charge on the element. Any doubt? Any doubt, guys? Okay, so we'll see how some of the compounds will be formed by this property, that is electropositive property and electronegative property. The first one which we consider, or which I am going to explain, is formation of sodium chloride. In a sodium chloride, sodium is a metal, chloride is a non-metal. So we have seen the sodium in the previous case. So sodium contains how many electron in the valence shell? 1. Chlorine require how many electron? 1. So sodium contains 1 electron. I have written only the outermost electron here. 1 electron in the outermost. And chlorine, if I consider, there are 7 electron in the outermost shell. 1, 2, 3, 4, 5, 6, 7. So chlorine require 1 electron to attain octet structure. Sodium should lose 1 electron to attain the octet structure. So in order to do that, the sodium will donate its 1 electron and becomes positively charged ion, and chlorine gains that 1 electron and becomes negatively charged ion. Because losing of electron or loss of electron means positive charge, gain of electron means negative charge. So this is how the sodium chloride first converted into ionic form and finally converted into solid sodium chloride. Understood? Any doubt? You can hear me, right? Okay. What happened? No doubt. Okay. So what is the next? Here you can see sodium, the same thing which I told now. Chlorine require 1 electron, sodium contains extra 1 electron. So they combine with one another to give NaCl. So atomic number of sodium is 11. Its electronic configuration is 281. 1 valence electron. If it loses, it becomes Na plus ion. Atomic number of chlorine is 17. By gaining 1 electron, it becomes Cl minus ion. So the transfer of or the attraction exists between the Na plus and Cl minus because both are of opposite charge. And finally, they lead to the formation of sodium chloride crystal. The next, we can see the example of magnesium chloride. When we consider a magnesium, the atomic number of magnesium is 12. So the electronic configuration of this magnesium will be 282. So in order to have 8 electron in the outermost shell, it should lose 2 electron from it. When it loses the 2 electron, now what happens? It becomes 2, 8. And at the same time, the chlorine, as I already told, it is of 1 electron deficient element. It gains that 1 electron and becomes a Cl minus. Okay. How magnesium chloride will be formed? Magnesium containing 2 valence electron. You can see here 2 valence electron combines with the chlorine, which require 1 electron only. Since it requires 1 electron, 1 magnesium can combine with 2 chlorine atom. You can see here, this electron goes to first chlorine, this electron goes to second chlorine. Since it requires 1 electron each, 2 chlorine atom can combine with 1 magnesium atom and it forms magnesium. Since it has lost 2 electron, carries 2 plus, and non-metal which carries -1 charge each. -1 because magnesium has given 1 electron to chlorine and 1 more electron to second chlorine atom. And because of the attraction between these two, they combine with one another and gives magnesium chloride. Any doubt? Any doubt? Understanding, right? Okay, so this is how the magnesium will be converted into magnesium chloride. Again, the explanation they have given, that is magnesium with atomic number 12, which by taking 1 electron from chlorine becomes magnesium chloride. And during this transformation, the magnesium loses 2 electron and the chlorine gains the 2 electron to form magnesium chloride. Next, we have to study about the ionic compound. Ionic compound means the compound formed between the ions. That compounds, we call it as ionic compound. So what are all ionic compounds? Ionic compounds are formed by the transfer of electron from metal to a non-metal. So whatever example we have seen now, magnesium chloride, sodium chloride, that are all the ionic compound, because in case of sodium chloride, sodium has given its electron to chlorine and chlorine has accepted, and sodium is a metal, chlorine is a non-metal. So properties of ionic compound. So what are all the properties it has? The first property, the same as definition, it is formed by or it is made up of transfer of electron from metal to a non-metal. Okay. And next one, they are crystalline solid. So they are crystals. When we touch it, we can feel the crystals in that. If you see the sodium chloride, that is stable salt. If you touch it, you can find the crystal in that. So they are crystalline in nature and has high melting point as well as boiling point. The high melting and boiling point is because of the strong ionic bond exists between the positively charged metal and negatively charged non-metal. The next is they are soluble in water but insoluble in organic solvents. Okay, they are soluble in water, like dissolves in like, because these metal compounds are not having carbon in it. Carbon compound dissolves in organic solvent, non-carbon, that is inorganic compound soluble in water. These metal, non-metals comes under inorganic compound. So they are soluble in water, but they are insoluble in organic solvent. The next is they conduct electricity in a molten state or in a solution state. We all know that the sodium chloride conduct electricity, but not in a solid state. Why not in a solid state? Because in solid state, the metals, the ions are not available. In solid state, it is present as NaCl. But in a molten state, it is exist in the form of Na plus Cl minus. So since there is a presence of free ion, the free ions are also responsible for the conduction. So in a solution state as well as in a molten state, there is availability of free ion, and that free ions are responsible for the electrical conductivity. You can see this experiment. In this first container, they have taken the molten or a solution form of the sodium chloride, and here they have taken solid sodium chloride. So if we consider a solid sodium chloride, the sodium chloride does not produces any electricity. Whereas if we take a molten form, it conducts electricity, and you can see the bulb is glowing. Okay, so this is about the properties of ionic compound. That is, they are having they are formed by the transfer of electron. They are crystalline in nature. They have high melting point. Boiling point is also high. They are soluble in water, insoluble in organic solvent, and they conduct electricity. Next, we have to see about the occurrence of metal. Occurrence means where do we find these metals? Okay, so occurrence of the metals we have to see, that is from where we'll get the metal. So metals like gold, silver, platinum, the noble metals, are found in a free state in earth crust, because we are obtaining all the metals from the earth crust by digging. Okay, why we can get it in a free state? Because they are less reactive. But other metals are more reactive, and they'll be present either in an oxide form, carbonate form, or sulfides form, or halide form. So from that, we need to extract the metal. So that metals, along with the impurity, are called minerals. Minerals means the metal compound or a compound of the metal which is present in the earth crust. Okay, and when we consider a metal, for example, if I consider iron, the iron will be present in an oxide form. It is also present in a sulfide form. It is also present in a halide form. All of them together, we call it as mineral. But the extraction of the metal will be taken by, the extraction of metal will be carried out by taking any one form of these metal. So if I consider iron, I told oxide is there, sulfide is there, halide is there. Out of the three form, the more efficient method to extract the iron is from iron oxide. So from the oxide form, we have to extract the iron. That oxide form of iron from which we extract the metal is called ore. So ore is also a mineral from which the metal will be extracted. Okay, the one more term we have under metal or extraction is gangue. Gangue means along with the metal, I told that since it is present in a earth crust, there will be a sand particle, there will be a rock particles, there will be a clay particle which is attached to the metal. That particles which are attached or which is present along with the ore is called gangue. Okay, gangue is the impurity present along with the metal. So next we have to study the extraction of metals from their ore. How do we extract metal from the ore? So that I'll continue in the afternoon class. So any doubt till here? Any doubt till here? Understood about the metals and non-metals? Next, we have to see how do we extract them. Okay. Okay. So I'll end the meeting then. We'll continue in the afternoon session. Okay.